Hi, so today we're going to be talking about using PathPlanner for creating FRC paths and autonomous routines. It's a motion profile generator for FRC robots, and essentially you can make paths using the graphical user interface for the drivetrain, and then you can also make autonomous routines that pair together these paths with other events like lifting the elevator, auto align, outtaking, intaking to create full-fledged autonomous routines. You can download PathPlanner from the Microsoft Store, or if you have a Mac like me, you can go over here and then download either of these should work. So make sure that you have PathPlanner downloaded. You can always refer to this website if you need help with the library or the graphical user interface. Okay, let's get into PathPlanner. So I'm going to open up PathPlanner, which I have downloaded, and I'm just going to give you a brief rundown of the application. Over here on the navigation menu, let's first look at this top part. So this is the project that I'm currently in, and it's important that you're in the right project so that you have the right paths and autonomous routines. As you can see, when I click on Open Project, it'll take me to the local project that's on my computer. And with that, I will have all these paths and autonomous routines. The next part of the navigation is the telemetry window. So this is really useful for when you're actually testing your autonomous routines on the robot. Right now, I can't connect to the robot, but if I was doing this on an actual robot, I would connect to the robot's Wi-Fi, and then I would run my autonomous path, and it would show me on PathPlanner the predicted or like the expected path, and then where actually the robot is moving, so I can see how off my path is and then tune it appropriately. So let's go back to the project browser. So you're going to see over here on the left, there's various paths, and then on the right, there's autonomous routines. And like I mentioned, paths are essentially just for the drivetrain itself, and autonomous routines have a lot of complex actions together, like the auto align and the outtake, and we'll get into that in a sec. Now, another important part about PathPlanner is the robot configuration. You want to make sure that the config values for your robot are correct, and you're going to have those listed in the constants file as well. So you're going to have right over here the robot mass, and these values you'll get from the catters. But then these values you need to tune as programmers. You're going to use the telemetry thing that I just showed you. You're going to path the simple straight path for translational auto P and see how off the robot is. Tune that P value until you get the path that you want. And then same for rotation, you're just going to have the robot turn, and until you get the right angle being turned, you're going to keep tuning that P value. You also have the settings option down here where you're going to put in all the important values for the robot. So make sure that these are accurate so that when you're creating autonomous routines in PathPlanner, they can actually be translated to the robot appropriately. Okay, let's get into creating a path. So I'm going to go over here, click on Add New Path, go into here, and I'm going to edit the path name. We're just going to call it Video Path for now. In this path, you currently have 2 waypoints, and this is the start point and the end point. And those are essentially just like the points the robot is going to go through. So to add a new waypoint, you can literally just double click, and there we go. Now I have this intermediate waypoint, which is currently called waypoint 1. Waypoints can be edited. So when I move it up, the Y value is changing side to side, X value is changing. I can also change the heading of this waypoint by modifying the direction that it's going to turn into. And then I can modify the control length, the next control length, or the previous control length of the waypoint as well. So let's just play around for a sec and try and get this to like go in a somewhat clean path. So now it's like doing kind of a U shape. But if you see what's happening over here with the wheels, it's kind of doing this wonky like wheel switch up. So that's because the heading over here is telling it to go up here, but we can just flip this down and now like it should have a cleaner U. Another thing you can add at waypoints is rotation targets. So let's say I wanted like at the end point, I just added a rotation target for this endpoint. So now I can change like the degrees that I want it to rotate at the end. So let's put like, now you can see that on the way to this path, it's going to turn and it's doing this rotation target. I would say ideal starting state and goal end state are also pretty important. So goal end state, especially for auto align, if you ever have the robot driving to somewhere and then you're auto aligning, you don't want it to like completely stop before it auto aligns, and that's why you're gonna have like the velocity set to a certain like kind of a low value, maybe like 1 or 0.5 or maybe even 2, so that it's not completely like stopping and then auto aligning. Rather, it's just one fluid motion. Also, global constraints. These are like the values that apply to all paths all the time. And it's like your max velocity, max acceleration. It helps make sure that your paths are safe and consistent. But you also can have constraint zones. So for instance, if I really want the robot to like slow down a lot when it's turning, then I'm gonna go over here and I'm gonna say from this area where it's about to turn to like this area where it's like done turning, I want like the max velocity to be like really low, and I want the max acceleration to be really low, and I want angular velocity and acceleration to also be really low. So you can see how it's slowing down a lot and then it's speeding up again towards the end. And if we reduce this even more, you can see how like more abrupt that is. When we're going into the intake section, the coral station, we don't want to ram into there because you know what happens when we do that. So that's why we typically add a constraint zone when we're about to go to the intake. Path optimizer. So path optimizer helps us make the most optimized path, but the path optimizer doesn't account for everything. Like it doesn't account for your game strategy or necessarily like what the goal of your path is. Let's see for my cases what's going on. I mean, for my cases, this looks pretty good because I don't really have a purpose with this path. So we're going to go ahead and accept it. Okay, over here is like the runtime that your path would take. Okay, I'm pretty happy with this path. So let's move on to making an actual autonomous. Now, just a brief overview. When I'm making an autonomous, I typically break it down into various segments. So I call it like based off of the autonomous that it's for, right or left. And so for left, I'll have like the segments going to auto align and then going from auto aligning for the first coral to the coral station and then going back. They're just all separate paths. And then you combine them in an autonomous and it makes a full autonomous routine. Before we look into we get too in depth into this, I just want you to notice the fact that we have like a deadline group over here and then we have a sequential group over here. It's kind of important to know the different command groups for making autonomouses. So let's look over here. Let's refer to WPILib documentation. In the WPILib API, you can see that there are like, I would say 3 main command groups that you should know for making autonomous routines. Parallel command groups, sequential command groups, and then parallel deadline groups. So in a parallel command group, it's pretty self-explanatory. The commands are going to be run in parallel. So if I said I want it to drive for like a really long path that's going to take 20 seconds to drive, and then I want it to outtake for exactly 3 seconds, it's going to outtake for 3 seconds while driving for 20 seconds. And so command group won't stop until the driving is done, even though the intaking might have stopped. So essentially it ends when the last command ends. Now, a sequential command group. Also, if you ever have written code and you do like elevator go up, dot along with actuator go up, that's an example of a parallel command group. A sequential command group is essentially running commands in a sequence. You're going to be intaking and then you're going to drive. And so it's going to finish the intaking and then it's going to do the driving. So it's like doing each command in the group sequentially. Now, parallel deadline groups is pretty important for autonomous. Basically, what this is that it's going to run the commands in parallel and then it's going to end when the deadline command ends. And that's going to interrupt all the other commands that are still running at that point. So let's say I have the same example. I'm going to be outtaking for 3 seconds and then I'm going to be driving for like 20 seconds. I want to stop driving right after I'm done outtaking. And so I'm going to put the deadline group as the outtaking command, and when that ends, it's going to interrupt the driving command. So we can see this being used over here. I have like a sequential command group just to do the first segment and then to do all of these things. But a lot of like the deadline group over here, the deadline command is this wait command. And then it's like going to L4 and auto aligning. And the reason why we have a deadline group is because we don't want the robot to continuously keep auto aligning and like spend a lot of time just trying to get to the perfect auto alignment, because we need to move on to the next segment. And so after you've gotten somewhat good, like aligned after like 1.2 seconds, which is like apparently optimal time to just align, then you can end this group. So that's when we're like, hey, the auto align is good enough, let's just stop it. And then we move on to the next deadline group. So we're not going to keep on outtaking coral. We're just going to wait for 0.4 seconds and outtake coral for just that amount of time. Using deadline groups helps make sure that you're kind of keeping your code modular. And so it's like when something doesn't work, if something doesn't work, it's not affecting everything else, because you can just say like, I'm just going to end it. Like, I'm going to end this entire sequence at this command. If it doesn't work, it doesn't work, but I still have a few other corals that I can try scoring. So yeah, these are again some examples of deadline groups that are used. Let's kind of take a look at what this is. So intake coral, what is this and why am I able to call it? We know third segment, fourth segment. These are all just paths that I have, and I can like select out of all the paths which one I want. So let me go back and reselect third segment. Let's go to the code. So in your code, in your robot container file, you're going to have a method called register name commands. And in this method, you can put the name that you want to show up on PathPlanner and then what you want the command to be. So right now I have it L4, and that means that I want the elevator to move to the L4 position. At the same time, I want the actuator to move to the L4 position. And then I also have a command for like right auto align, which is just auto align to the right, or left auto align, which is auto align to the left. And then intake and outtake. And these are all the commands that you're registering using this in this method. And then up here, call this method, and that's going to make sure that all of our name commands are registered. Also, one thing to note about PathPlanner and just your Auton routines is that when you click under this main dropdown, you're going to see two overall folders. You're going to see your code that you actually wrote, and then you're going to see this deploy folder. And this is where all the auto paths and autonomous routines are saved. So when you build, like, you're sending this stuff, and when you deploy, you're sending this stuff to the robot. This isn't stuff that I actually like went in and wrote. It's just generated when I'm like changing it in the graphical user interface. And so just make sure that whenever you're like building code that you actually have the right paths showing up here. That's pretty much everything you need to know for this. So I'm just going to show you once again, like, you can select any of the named commands that you have in your code. You know, let's make a new autonomous routine so I'm not messing with whatever this is. So I'm just going to call it video auton. If I go in here, follow path, I'm going to have it follow the video path, and then I can have let's do a parallel deadline group. And then I want the parallel deadline command, I want the deadline command to be a wait command, and I want it to wait for 2 seconds. So in those 2 seconds, I'm going to have another name command come under it, and let's have like the LEDs go purple. Let's have the elevator go up. Let's also have like a right auto line to happen after that. And then we can go in and we can add like a wait, maybe like 0.1 second, and then you can add an outtake. Honestly, a lot of this stuff, for me personally, it's just like tweaking the values and the orders and the command groups that you use and the times. Just keep on modifying it until the auto path is consistent and it's optimal and it's safe. And in terms of safe, I mean things like that, constrained zones and slowing down the path. And then you can just see what's happening over here. Again, remember that this time is only telling you the time for driving, and it doesn't account for any of your actions. But yeah, that's your path. That's your autonomous, and you can add more. You can have it follow more than one like path. Make sure that your paths actually connect. This is a bad example. Make sure that your paths, like the end of one point of one path is the start of another path, and that's something that you're going to want to do in your paths themselves. so that when you actually make an autonomous routine, it's not like this. But that's pretty much it for Path Planner and autonomous routines. If you have any questions, let me know, and I hope this helped.